Okay, this is number 16 on, this is section 1.1. And this question was asked a couple days ago. It was after, by Kendall Porth. And it was after the submission already, but I'm sorry, I'm just responding right now. It's actually one of the problems that I graded for your homework. That's why I didn't put the video up, because the solution is up right now in Moodle, but I'll go ahead and do it step by step because I think it's a very important problem. So we have the differential equation, 3y double prime, well, that's a horrible double prime, 3y double prime plus 3y prime minus 4y equals 0, and we want to substitute y equals e to the rx into this given differential equation because we want to determine all the values of the constant r, right? So this is my constant. So let's go ahead and just substitute the values, or actually the function, right? The function, the solution to this differential equation. So we have 3 times e to the rx, right? Double prime plus 3 e to the rx prime minus 4 times e to the rx, right? No prime because there isn't a derivative. And here, this is where a couple of you made a mistake on the homework. Not all, but it was a very minor mistake. E to the rx, okay, this means, right, this guy, we're going to take 2 derivatives. So here's one derivative, and then after that, I'm going to take another derivative to make it the second derivative. And then this guy, this is pretty easy. The derivative of this exponential function, right, it's in the form e to the kx, or some constant x, which is re to the rx minus 4e to the rx equals 0. And then this guy, right here, right, we can take the derivative, which we just did. And that guy is re to the rx, right, but we still have to take the derivative, plus, and I'm just going to go ahead and write these, just for now, it's going to be the same, really. So let's go here, 3 times, well, now the derivative of this guy, right, this is just a constant, right, so we don't necessarily have to use a product rule. You can if you'd like, but it's just a constant, so it's just going to be r times, and then we take the derivative of this guy, which of course is re to the rx, and then let's just continue writing the 3re to the rx, right, I'm just bringing these guys down, minus 4e to the rx equals 0. Okay, so we have 3r squared e to the rx plus 3re to the rx minus 4er x equals 0. And this is a very nice equation, a very popular actually equation. It has a sort of a quadratic form because of this r squared. But let's first notice that there is a greatest common factor, right? I can factor that e to the rx, right? It's common into both, well, the whole expression. So we're left with 3r squared plus 3r minus 4 equals 0, right? If we distribute this guy, we're just going to get this guy. So we have a nice polynomial looking function here. It's obviously quadratic. However, this polynomial is not factorable in the real numbers. If you try to factor it, it's not going to factor with real number solutions. It's actually going to, well, I should actually be careful. It is going to be real solutions. It's just very hard to factor this polynomial because we're going to have square roots and so forth. So, okay, let me just go ahead and work it out. So this guy, this one was, right, this is 0, or 3r squared plus 3r minus 4 equals 0. So when is e to the rx equal to 0? Well, that's never, because this is the e to the rx function, right? And again, let me get this one, right? This is your output, right? Y equals e to the rx. So when does when does the curve actually touch the x-axis, right? When is y 0? And that's never true. So here we can just use a quadratic formula, right, where a is 3, b is 3, and c is -4. And so x equals -3 plus or minus, let's see, b squared, so that's 9 minus 4ac, 4ac, right, and then we're just computing over 2a, which in this case is 6. And let's see, it's going to be 9 plus, what do we have, 12 times, or 16 times 3, so that's 48 all over 6. And we're almost done here, -3 plus or minus. So 48, 58, 57, right? So, and actually I really should say r, right? I wrote x, but I really should say r. So these are my two solutions. R is equal to -3 plus the square root of 57 over 6, or -3 minus the square root of 57 over 6. So again, this is from the very first assignment, but I did want, I'm actually glad Kendall asked me to do a video, because you will be seeing this. This is going to be very helpful in chapter 2, in finding distinct roots and so forth. Hopefully that clarified and not made, yeah, I hope I didn't make it difficult. Okay, that is number 16, 1.1.